that because some of you may want to watch this video again because polynomial long division. Exciting stuff. So here we go. Let's get up our buzz screen to see what we're going to be working on. Going to the grade screen, we should have the test done last week. Last week was test week, which was good because we didn't have class week last week due to PSAT, which is great. We didn't have to cover anything last week. It was just a test. So that didn't affect us a whole lot. But the Module 2 test, you should be done with everything up to that. We should be starting Module 3. And you see, we've got two things we're covering: polynomial long division and then polynomial synthetic division. That doesn't mean synthetic as in it's not natural. Well, maybe it is not natural. I don't know. So we're going to spend 2 weeks on this. Then we'll do theorems of algebra and the rational root theorem, Descartes. There's a lot of really good stuff in this whole unit. Hopefully we'll have time to get through all that. And then we got 2 lessons in the quiz. So 2 lessons each week, and then a quiz on week 3 over everything we're learning up here. So let's get into the polynomial long division. This is so exciting. I'm going to close the Module 2 folder, open the Module 3 folder, and let's get into it. Take a look. It's probably going to start with just like kindergarten or second grade division. See, polynomials in the real world. Well, that's a good question. So a cantilever, if you've ever heard of a cantilever, it's a beam that's anchored only at one end, but can still bear the weight of some force. Like, this is a good illustration of that. It's only connected right here, but due to the counterbalance in the back, it can hold a lot of weight on this end. These beams are used in a variety of applications, from bridges to airplanes to micro-electromechanical systems. Hey, use that in Scrabble and you'll win the game right there. Micro-electromechanical. The amount of bending that a cantilever undergoes is a third-degree polynomial function based on the cantilever's length. So engineers do use a lot of math. Many real-world situations can be modeled using polynomial functions. That's why it's important to know how to use them. So one key feature is when these polynomial functions equal 0. So like when we solve quadratics, we set it equal to 0 because that tells us important things. This makes it easy to construct a rough graph and know how the function will behave. So we're going to learn how can long division be used to find the factors of a polynomial function. So when you first learned long division, you probably didn't understand its purpose, right? Now that you're older and wiser, you can see many uses for knowing how to divide. Let's say you accept a part-time job working in a bakery. So the baker sells a bag of rolls that contain 13 rolls in a bag. It's called a baker's dozen, right? A baker's dozen is generally 12 plus an extra one. That's why they call it a baker's dozen. So the baker made 158 rolls before leaving for the evening. He said, hey, before you go home, package up all these rolls, put them in baker's dozens. So you got to figure out how many bags do I need, right? So you go grab the bags and, package them up 13 at a time. So this is a situation that you could be encountering in many jobs. You grouping a given number of items evenly. So here you need to put 158 rolls into groups of 13. So you'll just divide 158 divided by 13. So we won't spend a long time reviewing how to divide. Like this divides 13 into 158. That is elementary school. I'm sure you guys can divide. But let's talk about the terms that we use. The number that you're dividing into is the dividend. Like in this case, it's 158. We're going to divide into. The divisor is the number that we're dividing into the dividend. So 13 divided into 158 is the divisor and the dividend. And the answer you get on top is the quotient. Right, the quotient. So when you divide 158 by 13, the first 13 into 15 goes once. You multiply 1 times 13, subtract to get 20, bring down the 8, 28. 13 and 28 goes twice. Okay, multiply back, you have a remainder. So in this case, we have the dividend of 158, the divisor of 13, and the quotient is 12. and we have a remainder of 2, which we can put the answer as 12 and 2/13, right? Because 2 out of 13, since that's the remainder, you can put it like that. So you'll have 2 rolls that you can eat on the way home after you package up the 12 bags. Right? Or you can sell those 2 and sell 2 individuals. So just a basic review on long division. So the steps you use to divide polynomials are exactly the same that we use when dividing integers. So here's a little acronym. Discovering math solutions bring rewards, right? That means divide the D, multiply, subtract, bring down the next number, repeat. So we're going to look at an example on dividing a polynomial by a monomial. So monomial means there's only one term. So we're going to watch this video first, and then we're going to start notes on this real soon. But let's go ahead and check out their example starting out.
Before you can start with the division process, you need to set up the problem. The dividend is the trinomial 2x cubed minus 10x squared plus 18x. And the divisor is the monomial 2x. Remember, the steps in the division process are divide, multiply, subtract, bring down, and repeat. First, divide. How many times will 2x divide into 2x cubed? You can think of this as dividing 2x cubed by 2x. 2 divided by 2 is 1. But what is x cubed divided by x? When you multiply variables, the exponents are added. When you divide variables, the exponents are subtracted. So 2x cubed divided by 2x is 1x squared, or just x squared. This gives you the first term in the quotient. Next is multiplication. Multiply x squared by 2x. The product is placed underneath the first term of the dividend. Then it's time for subtraction. Subtract 2x cubed from 2x cubed. Now bring down the next term. Remove the 0 since adding or subtracting a term from 0 doesn't change the value of the term. Repeat the steps of long division until all the terms of the dividend have been exhausted. Time to divide again. Divide negative 10x squared by 2x. You can think of it this way. Negative 10 divided by 2 is negative 5. But what is x squared divided by x? Subtract the exponents. So negative 10x squared divided by 2x is negative 5x to the first power, or just negative 5x. Place this above the second term of the dividend. Multiply. Negative 5x times 2x is negative 10x squared. Subtract. Negative 10x squared minus negative 10x squared is 0x squared. Bring down the next term. Again, you can remove 0x squared since it just has a value of 0. Repeat the process. Time to divide again. Divide 18x by 2x. You can think of it this way. 18 divided by 2 is 9. What is x divided by x? Think about it. What is 11 divided by 11 or 100 divided by 100? The answer to all these questions is 1. Any number or variable divided by itself will result in 1. Another way to look at it is through the subtraction of exponents. Any number or term raised to the power of 0 equals 1. So 18x divided by 2x is 9. Place this above the third term of the dividend. 9 times 2x is 18x. 18x minus 18x is 0x. There are no more terms to bring down. Therefore, the quotient has been found. The answer is x squared minus 5x plus 9. Check your work by multiplying the quotient by the divisor. This product is the same as the dividend, so the quotient x squared minus 5x plus 9 is accurate.
All right. I love that because this tells us the two factors. Those are the two factors that you can multiply together to get the original dividend. So polynomial long division is used to find factors, because factoring an x to the third equation could be kind of tricky, but we could see we could pull a 2x out of all of that, and this is what's left. So this is what we're going to get into. Learn more about polynomials divided by monomials. See, this is another example. So we'll go ahead and do this example on paper just to have an example of monomials divided into polynomials. Okay, so to have an example in our notes here, if we're just dividing negative 3x into this polynomial, the first thing we need to do is take the first term and divide it by the negative 3x. So negative 3 into 12 goes negative 4 times, right? Because negative 3 times negative 4 is 12. And x divided into x squared is just an x. So if we multiply those two back together, we should get the 12x squared, right? X times x is x squared. Negative 3 times negative 4 is 12. So now let's multiply those. It goes 12x squared. And we got to subtract that. So 12x squared minus 12x squared is just 0. So we bring down the next term, negative 27x. How many times does negative 3x go into negative 27x? Well, negative 3 goes into negative 27 a positive 9 times, because it's a negative divided by a negative. X goes into x 1 time, so it's just 9. And 9 times negative 3x. 9 times negative 3x. And when we subtract that, subtracting a negative means we add, and this is just 0. So there's a remainder of 0. So the factors, this tells us the factors of 12x squared minus 27x are negative 3x and negative 4x plus 9. Those are the factors. And we can test that by multiplying it. Negative 3x times negative 4x plus 9. We just have to distribute. Negative 3x times negative 4x is a positive 12x squared. Negative 3x times 9, negative 27x. So we can see when we multiply those together, it does indeed equal the original equation, because there's no remainder. There's no remainder. That makes that easy to check. But that's how we find the factors of that, is by using long division. And it's not too bad when it's a monomial, one term. But we're going to increase what we're doing here. All right, let's example 2. That's still dividing by a monomial, so it takes you through the steps if you need that. Now, why is this off my page? Okay, there we go. Let's go to page 2. Polynomial division of a polynomial by a polynomial. So now we're dividing by x minus 6. So let's see if we can work that on paper before we watch how they explain it in their videos. So let me write this down. This will be fun if I remember all the steps here. So now we have two terms. So we're going to divide that into the first two terms here. And the only term that we worry about when we're using two terms is the first one. How many times does x go into x squared? And we write it over the second term because we're dividing into two terms. X goes into x squared x number of times. Now let's multiply. X times x is x squared. X times -6 is -6x. And we're subtracting that. This is where we get messed up. We're subtracting this -6x. If we just see -2x and -6x, we might want to put -8x. That would be wrong because we're subtracting it, which means this would be a positive. X squared minus x squared is 0. -2x minus a -6 means add 6. So this is actually 4x. And now we bring the next term down. How many times does x go into 4x? 4 times. 4 times x is 4x. 4 times -6 is -24. Subtract this. It helps put that in parentheses when you're subtracting, just to help you remember. This isn't just -4x minus 24. It's negative subtracting a 4x minus 24. So this is 0. 4 minus a negative. 4 minus a negative means add. So the answer, when you divide this by x minus 6, the answer is x plus 4 plus 28x minus 6's. There's a remainder. There's a remainder. Yes, Daniel.
Wait, so how did you get the 24 as opposed to 16?
When I have the 4 up here, I multiply 4 times x and 4 times -6. 4 times x is 4x. 4 times -6 is -24. 4 times -4 would be -16. But 4 times -6 is -24. We good? Okay. So this one has a remainder. So what that tells us is x minus 6 is not a factor of x squared minus 2x plus 4. That's not a factor. For the same reason that when we take 15 and divide it by 7, we get 2 with a remainder. Oh, yeah, how to do your remainder there. No. We get 2 with a remainder of 1, right? Because 7 is not a factor of 15. We get a remainder. Because 2 times 7 is 14, and we have a remainder of 1. So anytime you divide something into another number and you have a remainder, you know that's not a factor. So if you're struggling with any of this, break it down to something simple that you do know. You do know that when there's a remainder here, 7 is not a factor of 15. Same thing with a polynomial. If we divide this into that and there's a remainder, this is not a factor of that. If you factored this, this would not be one of the factors. Not. So that's a handy way to figure out, is this a factor of that? Well, let's divide it and see. Let's divide it and see. All right, we'll watch their video and see if they explain anything any differently than what we just did.
Divide x squared minus 2x plus 4 by x minus 6. First, set up the division problem, where the dividend is x squared minus 2x plus 4, and the divisor is x minus 6. When dividing integers, the digits in the dividend were evaluated separately. With polynomials, focus on the terms. There are 2 terms in the divisor. So count over 2 terms in the dividend to determine where the first term of the quotient will be placed. When dividing a multiple term polynomial, The first term of the dividend is divided by the first term of the divisor. So ask yourself, what is x squared divided by x? Next is multiplication. Similar to division by a monomial, the quotient will be multiplied by the divisor. Multiply x by x minus 6. Be sure the quotient is distributed to both terms of the binomial divisor. Place the product underneath the first two terms of the dividend. Now it's time for subtraction. Be very careful here. When subtracting a binomial, there is a -1 that needs to be distributed to each term before like terms may be combined. Once the -1 has been distributed to each term, the subtraction sign becomes an addition sign, and the like terms may be added. Bring down the next term. Repeat the steps of long division until all the terms of the dividend have been eliminated. Time to divide again. Divide 4x by the first term of the divisor x. Place this above the third term of the dividend. Since 4 is positive, it is added to the first term of the quotient. Multiply 4 by x minus 6. Subtract. Don't forget to distribute the -1. There are no more terms to bring down. Therefore, 28 is the remainder. Remainders are written as fractions, with the divisor as the denominator. The quotient of x squared minus 2x plus 4 divided by x minus 6 is x plus 4 plus 28 over x minus 6. Notice that there is an addition sign between the fraction and the rest of the quotient. This is because the remainder is positive 28 and being added to x plus 4 rather than being multiplied. You can think of the remainder as another term of the quotient.
Correct. So if the remainder had been -28, this would be a minus 28 over x minus 6. But since it's a positive, we add it. So they differentiated just a little bit in the way they said it. The way they said, instead of subtracting, you can just distribute that -1 and then add the terms. It's the same thing. If we have 10 minus 7, we could add a -7 by distributing. See, it's the same adding a -7 or subtracting 7. So it does the same thing. They end up with the same answer. Just whichever way you think of that, and it helps you better. All right, let's look at more examples. Okay, here is another problem that is very, very critical to understand, because this is where we will make mistakes. We have f of x that equals 9x squared plus 6. We have g of x that equals 3x minus 1, and they want us to find f of x divided by g of x, which means when we set up the problem, we've got g of x out here because we're dividing it into f of x. But f of x is 9x squared plus 6. Now, I left a space in there for a reason. What's the x term? We can't leave any terms out. This is the same. This could have been written like this: 9x squared plus 0x plus 6. These are exactly the same. You agree? Yeah, I just wrote all the terms here, because generally when you start with the largest term, you have all the terms in between there. This is what we have to use when we divide. There is an x term there. It's just 0. So when we write it, we just skip that, because there's no need to write 0x. when we just write down an equation, right? This is kind of extra work that doesn't mean anything. 0x's doesn't mean anything. But when we divide into that, it's important to note there is an x term in there. It just has a coefficient of 0. But when we multiply, that's going to play pretty heavy. If we don't have that, we'll get a wrong answer. So 9x squared plus 0x. So we're going to put our first term over here, but we're just dividing 9x squared by 3x. So let me move that over where you can see that. 9x squared divided by 3x. Right, just the first terms. So this is 3, 9 divided by 3. X squared divided by x is x. So this is 3x times. That's how many times 3x goes into 9x squared. It's 3x. It's 3x times 3x is 9x squared. So multiplying back, that's 9x squared. 3x times negative 1 is negative 3x. Now, again, we're subtracting this. 9x squared minus 9x squared is 0. 0x minus negative 3x is a positive 3x. 0x minus a negative 3 is a positive. Plus 6. How many times does 3x go into 3x? One time. So 1 times 3x minus 1 is 3x minus 1. Subtract that, 3x minus 3x, 6 minus a negative 1 is 7. So if we divide 3x minus 1 into this, the answer is 3x plus 1 plus 7 3x minus 1s. Which means, again, this is not a factor of this because it does not divide evenly. But the big part of this one is we have to make sure to account for every term, whether it's written or not. Whether it's written or not, it's there. It's a 0. And we have to account for that when we divide. So they talk about that. You add that 0x in there. So then they go through the steps. Dividing, you get 3x. When you multiply that back, you get 9x squared minus 3x. We subtract. Remember, we're subtracting. Now, they went in and distributed it, but you're adding 3 because you're subtracting a negative. So we get a positive 3x. Bring down the next term, and then repeat, and we get a remainder of 7, which is what we had on there. Now, this says what would have happened if we have not included the 0x. We just said 3x. When we multiply it back, we get 9x plus 3x. But then we would have trouble adding the 6. That's really, really small. We'd have trouble adding the 6 to the 3x because they cannot be combined. Right? Because that's the important part of this. You know, when we write it underneath there, we're adding an x to an x. We can do that all day long, or subtracting an x from an x, subtracting an x squared from an x squared. But if we didn't have that term and this was the 6, we wouldn't be able to take 6 and negative 3x and subtract those. They're not like terms. That's why we need those missing terms, because we have to be able to subtract like terms, and we won't have that if we forget that 0 term. Take a look at the quotients, which is the answer up there. The division resulted in a remainder. This indicates that the divisor in each example was not a factor. That's what I was saying. If it were a factor, the remainder would be 0. So this becomes very crucial as you learn about polynomials. Application. All right, this is a good thing. When would this be useful to be able to divide in there? When would that help? All right, let's talk about this box. And we know the volume of this box is x to the third plus 4x squared minus 31x minus 70. That's what they gave us. That's the total volume. And we know volume is length times width times height when you're talking about a rectangle, a cube, a box. If we know the length is x plus 7 and the width is x minus 5, we don't know the height, but we could divide the volume by these length and width to find the height, because the formula is volume equals length times width times height. And if we want to know the height, we can rearrange the equation, divide by length times width to get height by itself. So the height is the volume divided by the length times width. So that would be a good one to work, because I think we have something like that on the test at some point or on the assignment or somewhere. I've seen something like that. So if the volume equals the length times the width times the height, we can divide by length and width to get height by itself. So the height is the volume divided by the length times the width. So the height would be the volume divided by the length times the width. So the first thing we can do is just multiply these together so we're not having to divide twice. X times x is x squared, x times negative 5, negative 5x, 7 times x, 7x, 7 times negative 5. So this is x squared. These are like terms. Okay, that is what length times width equals. So now we can take that, x squared plus 2x minus 35, and divide it into our volume, which is x to the third plus 4x squared minus 31x minus 70. Notice we're not missing any terms. We got a third, a second, a first, and a 0. So we didn't have to add any extra terms in there because they're all accounted for. But dividing this into this, we have 3 terms. So our first one's going to go right here. But all we're looking at is the first terms. X to the third divided by x squared is just x. So now multiply x times all 3 of these terms. X times x squared is x to the third. X times 2x is 2x squared. X times negative 35, negative 35x. Subtract. So if I subtract x to the third from x to the third, that's 0. This is a positive. 4x squared minus 2x squared is just 2x squared, because 4 minus 2. Negative 31x minus a negative, So I'm adding this. So this is 4x. Let's bring down the next term, negative 70. Now I'm dividing this into the first term. X squared into 2x squared. Well, if I divide 2x squared by x squared, it's just 2, a positive 2. So we've got x plus 2. Multiply the 2. 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times negative 35 is negative 70. Hey, look, if I subtract 2x squared plus 4x minus 70 from 2x squared plus 4x minus 70, so this is the height. Height equals x plus 2. So the length is x plus 7, the width is x minus 5, the height is x plus 2. And I know you're going to see problems like that. Now you could, if you wanted to, take this and divide it by x plus 7. And then whatever answer it is, then you divide that answer by the x minus 5. You could do 2 divisions in a row, right? You could divide by this one and then divide by that one with whatever answer you get. But I just multiply them together so I could do division 1 time. So they go through all the steps here. Let's see. Divide the numerator by the denominator, following steps, polynomial division. Enter your quotient. What did we end up with? We ended up with x plus 2. Yay, that was it. And then they show you how to get that. There's all that work that they did on how to do that. Going through the steps, dividing. They multiplied it together first as well. X squared plus 2x minus 35. And there's all the steps to get to the remainder of 0. There's another example. If you want it, polynomial divided by a polynomial. And this divides x plus 7 into 4x squared plus 27x minus 7. And they go through all the steps. So that's there if you need it. Let's look at the lesson summary. Steps to dividing polynomials. Divide, multiply, subtract, bring down, repeat. The same steps that you learned in elementary school with just numbers. Dividing 5 into 48. Use the same steps. Dividing 5 into 231. Same steps. This is the biggest part of this lesson, I think. This is where you'll really get messed up and get confused if you forget that you may have missing terms. You need to make sure and account for those missing terms. Like x to the 4th minus 1. This is a good one. This might be a good example. X to the 4th minus 1 should be x to the 4th plus 0x to the 3rd plus 0x to the squared plus 0x minus 1. When you use that in a division problem. And this is true. I should point this out. This would be true if we were missing a term out here. We would still put the 0 out here. Either one. If we're doing this kind of division, we have to account for any missing terms in either the dividend or the divisor. Account for missing terms. Missing terms is the big part of this lesson that you have to make sure and account for those when you're doing this. And then, of course, if the remainder is 0, that is a factor. Let's pull a practice problem to put in our notes before we move on. So that's just dividing by a number, by 5. So that'd just be x squared minus 12x plus 7, right? I messed with that one. Correct. 3 problems. Dividing by 7x. Let's go on and look at divide by x plus 7. Check my work. Oh, there's more down here. There's 3 problems there. Divide x minus 5. Check my work. 7x squared minus. There's one you have to account for the missing x term. But let's go to page 5. Let's see if we can get one that's a little trickier. Match each problem below to its correct quotient. So here's the 6 answers. If you divide this by 4, which one of those answers would you get? Well, you'd get that one. Divide by 6x. That's got to be that one. I want to get one we could put in our notes here. Well, that's got to be that one. That's a pretty good one. Let's do this one. Just to have another problem in our notes. Remember, we're really just concerned with the first term when we divide, but we got to see how many terms so we know where to write our first term of the quotient. So 24x to the 3rd divided by 3x. And if this helps you to write it out separately, please do. 24 divided by 3 is 8. X to the 3rd divided by x. And the way you do that is x to the 3rd is x times x times x. And on the bottom, there's just one x. So x divided by x is 1. So that leaves just 2 x's. Now remember, you can subtract. This is x to the 1st. 3 minus 1 is 2. So 8x squared is right here. And we're going to write it over the x squared term, which is the second term. Now we need to multiply this. 8x squared times 3x. 8 times 3 is 24. X squared times x is x to the 3rd. Then 8x squared times 4. 8 times 4 is 32. X squared Stays by itself. Okay, now we're going to subtract this. 24x to the third minus 24x to the third is 0. 41x squared minus 32x squared. Well, that leaves 9x squared. It's a positive. Bring down the next term, minus 3x. So how many times does 3x divide into 9x squared? Well, 9 divided by 3 is a positive 3. X squared divided by x is just an x. So 3x now multiplied over here. 3x times 3x is 9x squared. 3x times 4 is 12x. Again, this is where we get messed up. Remember subtracting, because I look at that and I want to just make it a 9x, right? Because negative 3 and plus 12. That's why on the examples they give, they like to do this. They like to say, if I distribute this negative 1 times 9x squared is negative 9x, and negative 1 times 12x is negative 12x, then I can just add these if I distribute. 9x, negative 9x, negative 3, and negative 12 is negative 15. So this is a negative 3 minus 12, or negative 15x. Whichever way you like to do that. If you like to subtract it, keep that straight, or distribute it and add them. Minus 7. So 3x goes into negative 15x, negative 5 times. Negative 15 divided by 3 is negative 5. X divided by x is just 1, so negative 5. Negative 5 times 3x is negative 15x. Negative 5 times 4 is negative 20. Subtracting that, this is subtracting itself at 0. Negative 7 minus negative 20 is a positive 13. So the answer, when you divide this into this, is 8x squared plus 3x minus 5 plus 13, 3x plus 4s. So we're looking for that answer, 8x squared. There it is, 8x squared, right there. And that one will go there, and that one will go there. And then you got another page over here. This one gives you f of x and g of x. And when you divide this, you should get one of these answers. So let's look at the assignment that goes with this, because I want to get to synthetic division. Divide by 7x. Which one of those is it? F of x divided by g of x. So you're dividing by 3x squared. All right. Divide by x plus 5. Divide by 2x plus 5. And here's one of those volume problems. This is the volume. Here's the width. Here's the height. Find the length. Again, you can multiply these two together and then divide those into this, or you can divide this into that, and then whatever the quotient is, you divide that by x plus 8. Either way, you should be able to get the answer. All right. We looked at polynomial long division. It makes you go, oh my goodness, Mr. Brock, seriously, dividing long division? Okay, now that we've looked at that, we're going to look at synthetic division. Synthetic division is a cheat code. It's dividing polynomials, but we're not going to use long division. We're going to use a shortcut, a cheat code. We're going to go straight to the answer quickly with synthetic division. This is where you want to make sure you take your good notes, because wow, this is so much quicker than polynomial. Because some of them polynomials, we had a lot of steps, right? The bigger the polynomials, the more steps we got to do. Let's look at synthetic division. Now here's the bad thing about this. There's only certain circumstances it works. Sometimes you have to do the polynomial long division. This only works if we're dividing by just like an x term. X plus 4, X minus 5, X plus 1, X. We can't do it if we're dividing by 3X squared minus 2X plus 1. It doesn't work. But when it does work, oh, it's so nice. Let's take a look at it. Let's jump into this synthetic division. Okay, this lesson starts off by saying, let's try these following problems. Add these numbers, 3, 3, 3, 3, 3, 3, 3, 3, and 3. All right, what'd you get? 3, 3, 3, 3, 3, 3, 3, 3, and 3. See, that's 6, 9, 12, 15, 18, 21, 24. Did you get 27? Or did you just take 3 times 9? In elementary school, you probably would have went 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. But there's a good chance, since there's 9 3s there, you just went 9 times 3 is 27. Because you're smart. You're not in elementary school anymore. How about this? If we divide 45,709,102 and divide it by 3. Okay, that's going to be some long division for you there, right? Or you're going to pull a calculator out. But there's a shortcut. There's a shortcut. If you add these digits together, 4 plus 5 is 9, plus 7 is 16, 24, 33, 34, 35, 36. 36 is divisible by 3. So that means this is also divisible by 3. Because it says, is 45,789,102 divisible by 3? Well, the shortcut is to add all those together, which they equal 36. Since 36 is divisible by 3, that means 45,789,102 is divisible by 3. Shortcut. Like it. 34 and 11. There's a shortcut when multiplying by 11 as well. Right? You can multiply by 10 and add 1, or there's this thing where you separate them and then you add what these are added together, 3 plus 7, put that in the middle. 34 times 11 is 374. You just take that and add them together and put that number in the middle of the 34. When you multiply by 11. It's a shortcut for multiplying by 11. 2-digit numbers multiply by 11, add them together, put that number in the middle. If we're doing 97, you're like, well, 97 is a 16. I can't put a 16 in the middle. Well, you carry the 1. You put the 6 in the middle and make the 9 into a 10. So 1067. So you can put it in the middle, but you carry the 1 over into the first digit. So each of these illustrates how a problem can be solved using a traditional method or using a shortcut. Remarkably enough, polynomials may be divided by binomials without the use of long division. Yes, you read that correctly. There is sometimes a shortcut. So we're going to learn about synthetic division. Okay, here's an addition. This is a review on long division. If you want to do another long division problem, we don't. We want to look at synthetic division. So this is the polynomial long division of this problem right here. Dividing x minus 4 into this 4-term polynomial. With synthetic division, look at this. We don't have any x's. We don't have any x's at all. It looks like this. It's just going through the steps, but the answer is already given to us right here. Let's work this out and see, what are they doing with this? Let's go back to the first step where we first put the synthetic division up there. Okay, I'm going to write this on our paper. This was polynomial long division, right? X minus 4 divided into all of this mess. It's like, yep, that's a bunch of steps. We got to go a lot of work. Synthetic division works just like this. We can take that x minus 4. If we set that equal to 0 and solve, that means x equals 4. So we're going to divide by 4. And we're going to go to this dividend, and we're going to pull out the coefficients. That's all I want. I just want the coefficients. This is the x to the third. This is the x squared. This is the x term, and this is the constant on the end. That's it. Just the coefficients. And I need a 4. Since this is x minus 4, I'm dividing by positive 4 because that's what x would be setting this equal to 0. Now, the first thing that happens is I'm going to bring the 2 down. I don't do anything with the first term. Bring the 2 down. Now I'm going to multiply. 4 times 2 is 8. And I'm going to add that. Negative 3 plus 8 is 5. Now I'm going to multiply. I'm going to add that because it's a positive number. Negative 12 plus 20 is 8. Now I'm going to multiply 4 times 8. And I'm going to add these together. Negative 16 plus 32 is a 16. I'm done. Like, what do you mean you're done, Mr. Brock? This is not the quotient. It kind of is. This is the coefficients of the quotient. That's just the coefficients because we only use the coefficients. So here's how this works. The answer. The first coefficient is a 2. Since this was an x to the third, the answer starts with x squared. 1 less. So this is x squared. Since that was a third, we divided out an x. So the answer is going to be an x squared. It's going to be 1 less than what we started with. So if that's x squared, then this is the x term. And this is the coefficient of just the number. And this is the remainder. 16x minus 4s, because that's what we were dividing by. This is all it took to divide x minus 4 into this long polynomial. Bring the first one down, multiply, add, multiply, add, multiply, add. There's my answer. I just have to convert it back into a polynomial. All right, I'll give you a moment to contemplate that. Put that in your notes to figure out how did we get from A to B. How do we decide what to divide by? We will do more practice problems. I want you to have that in your notes with some more practice problems. So this will be real easy when you start doing this. Love synthetic division. I wish we could use it on every polynomial, but it only works when we have just an x, unfortunately. So they work through it all and get the, see, do they ever give us an answer? No, they stopped right there. 2, 5, 8, 16. That's all we had. 2, 5, 8, 16. So using the same example, set up the synthetic division problem. So identify the opposite of the constant. Like x minus 4, we're using a 4, right? Because this is a negative 4, we're going to divide by a positive 4. Because if we move it, set it equal to 0 and move it over, x would equal 4, we're dividing by 4. With the problem we're dividing into, the dividend, we just want the coefficients, 2, negative 3, negative 12, negative 16. So we're dividing 4 into those 4 coefficients. First thing, bring down the 2. So they step through this here in your lesson too. So if you're a little confused, you can step through this. Then you multiply 4 times that number, which is 8. Now you add those. Negative 3 plus 8 is 5. And then we just repeat that. Now it's 4 times 5, which is 20. And we add negative 12 to 20 and get 8. Then we're going to multiply 4 times the 8, 32. We're going to add those to get 16. And this represents the coefficients of the quotient, or the answer. So we take those numbers and put them with the x squared, the x to the first, the x to the 0 power, which means it's just an 8, and then the remainder. The rule of thumb with synthetic division is subtract 1 from the highest exponent to make the answer. Started with x to the third, so in our answer, it's x to the second, because we divided out an x. What would have happened if the opposite sign of the constant divisor had not been used? What if we divided by negative 4? Because it says, oh, this is x minus 4. I'm going to divide by negative 4. Well, we'd ended up with an entirely different answer, which would be wrong. See, this is 2x squared minus 11x. It's supposed to be plus 5x. You got a plus 32 instead of plus 8. And your remainder is 144 instead of 16. So once you are comfortable with the steps for synthetic division, this process is fun to use. Really is. Let's look at page 2. Notice this is not a long lesson. All right. They have a video and another example and a third example and the lesson summary. All right. So let's do this on paper and then we'll watch the video. We're dividing this into that, however you write that. Maybe I'm supposed to have these on the other side with this symbol. But anyway, we're dividing this into that. So if x plus 7, that means we're using a negative 7 to divide with. Because this is a plus, we're going to use a negative. This was a negative, we used a plus. And we just want the coefficients. What's the coefficient here? X squared. Coefficient's 1, right? There's 1x squared. This coefficient is a negative 2, and this one is a negative 63. Okay, that's how you set it up. The opposite of the x term that you're dividing with, the divisor, the opposite of the constant, and the coefficients of our dividend, 1, negative 2, and negative 63. First thing we do is we bring down the first coefficient, the 1, and we multiply. Negative 7 times 1 is negative 7. Now we add. Negative 2 plus negative 7 is negative 9. Multiply, negative 7 times negative 9 is a positive 63. And negative 63 plus 63 is 0. So the answer, since this was an x squared, is just x minus 9. And there's no remainder. So that means this is a factor of this. And guess what the other factor is? Here's the other factor. X plus 7 times x minus 9. X times x is x squared. X times negative 9 is negative 9x. 7 times x and 7 times negative 9, like terms. So x squared, negative 9 plus 7. Looky there, that's exactly what we started with. Since the remainder was 0, you know these are both factors. The divisor and quotient are both factors of the dividend. Those are both factors. Now, if we ended up with, we could end up with something like 2x squared plus 5x plus 8. If this had a remainder of 0, you know, this and this would both be factors, but maybe this factors further. This may not be the simplest factor, but they would both be factors. with a remainder of 0. That wasn't the case up here. We had a remainder of 16. But with this one, these are both factors that would multiply together to be the original. Thank you, synthetic division. This was pretty simple compared to long division. All right, let's go back here and watch them do the same thing, see if they do it any differently.
The first step in the synthetic division process is to set up the problem. Start with the divisor. Identify the opposite of the constant. In this case, the constant is 7, so -7 is used. Place this value in the top left corner of the synthetic division problem. Drawing half of a box helps to separate it and reduce possible confusion. Now look at the dividend. Identify the coefficients of the terms in descending order. Remember to show the understood coefficient of 1 for x squared. Place the coefficients along the top row of the problem to the right of -7. Underneath those coefficients, skip a line and then draw a line. Now the problem is set up. Begin the synthetic division process. Start by bringing the leading coefficient under the line. Multiply the divisor by the number beneath the line. Place the product underneath the next coefficient. The vertically aligned numbers are added and the sum placed below the line. Repeat the process until all numbers have been used. The final step is to translate the synthetic division process into a solution. The bottom row represents the coefficients of the quotient. Since the dividend has a degree of 2, the quotient will have a degree of 1. The last number is 0, which indicates there is no remainder. Check your work by multiplying the quotient by the divisor. If the result is the dividend, the quotient is verified. Use FOIL to multiply the binomials. Combine like terms and there is the original dividend. It worked!
It worked. Yes, that's exactly what we came up with. So, okay. X to the third plus 3x squared. Oh, we need to do this example. Absolutely. Okay, I've written this down. And I started the synthetic division. We've got f of x is x to the third plus 3x squared plus 25. And g of x is x plus 5. We're supposed to find f of x divided by g of x. So I have... Yes, my computer just restarted all by itself. Everything went black and it shut down. So I'm on my phone while my computer is rebooting. I'm very sad because I thought we had this fixed. Tech has already worked on this 3 different times trying to fix this, and it's still doing it. So I'm very sad. Anyway, if you have pencil and paper, be working on that problem. It was x to the third plus 3x squared plus 25 divided by x plus 5. And as soon as my computer gets back up, I will continue with it, but this will give you a little chance to get a head start to see if you can do it. And there is a catch on this one. Let's see if you figure it out. Because the same thing that was true of polynomial division applies with synthetic division, that we have to make sure we have all the terms. New computer, I should have less problems. I've had the computer like, I don't know, 2 or 3 weeks now. Very frustrating. Gotta open my camera back up. All right. I had set up this, -5. Now I need to pull the coefficients. Let's see if your coefficients match mine. 1, 3, 0, 25. Same rules apply.
There.
Where's the x term? There's a 0x that's not accounted for. We have to account for that anytime we're dividing polynomials. Anytime. Anytime. So 1, 3, 0, 25. Bring the first term down. Negative 5 times 1. Add. Add.
What kind would a millipede have?
So when we divide x plus 5 into x third plus 3x squared plus 25, our answer is x squared minus 2x plus 10 minus 25x plus 5. 25x plus 5.
Perfect. Let's look at that very last.
Yes, that 0 is what's going to get us. If we miss anything up on synthetic division, that is the most common thing that's messed up. We forget that there's a 0x term that's not written just because we don't write that. We don't need that, right?
Okay, so start there.
Now they're doing the video. Yes, okay.
Number
I'm
six.
going to switch
So
over
what
and
type
show
of
their
circular
video.
braces do arthropods have? So open would be no base.
Oh, this has no.
Closed is the same.
Begin with the divisor x plus 5. Find the opposite. So we're going to divide by a negative 5 and put it in the top corner as we did for our synthetic division problem. Now we need to look at the dividend. X to the third plus 3x squared plus 25. So going in descending order, we notice that there's an x to the third, x to the squared, but the x term is missing. So we need to account for that with the 0. So write the coefficients to the right of the negative 5 that we have set up in our synthetic division problem. So the coefficients are 1, 3, 0, and 25.
Between, do they have a brain or not?
Now we're
Are there
ready
organs and firms and
to
organs
start
have
the
a
synthetic
brain?
division. Bringing the first term down. Got to put it back on the screen again. First coefficient, the 1 comes down. We multiply the negative 5 times the 1 and place it under the second coefficient. Now we add those. 3 plus a negative 5 is negative 2. We multiply the negative 5 times the negative 2 and place it under the next coefficient. And then we add the 0 and the 10. And then multiplying, we have the remainder of negative 25. Now we have to identify what our quotient is. What is the answer if we have 1, negative 2, 10, negative 25? We just fill it in
There we go.
with one less exponent.
Number
So
7.
x to the third is x squared with an x. And then the 10 is our constant because it's x to the 0. And then we do have the remainder, negative 25. So we just subtract 25, the original x plus 5 divisor. All right, that is what we're doing. Build your own polynomial. Oh, okay, so here you can create your own. It says do a 5th degree. So start with x to the 5th. And it wants to have a remainder of 1. Oh. Okay, so how would we do that?
The horseshoe crab's the only
So
one.
this is an interesting one. Create your own 5th degree polynomial that when you divide by x minus 4 has a remainder of 1. So that's kind of fun. Creating your own 5th degree polynomial. So they're using different numbers. They used a 1, 2, negative 20, negative 25, 5, negative 5, and a 180. And they had to change theirs to a 165.
Go down there. Let's see.
So everyone's answer could be different on this one. As long as it works, as long as it leaves a remainder of 1,
Where you see A, C, those are
the
good.
answer would be correct.
Third one where you have A, look at that one.
All right.
There you go.
Look back at the quotients of 1, 2, and 3. One of them had a remainder of 0. That means that this is a factor. So when the remainder is 0, not only is the divisor a factor, but the number used in the synthetic division makes the divisor and dividend equal to 0. Oh, math. So here's what they're saying. We go back and find one that we had a remainder of 0. Okay, so I wrote down, I found this one that we did that had a remainder of 0. So I wrote down the original function. I didn't write it well, but I wrote it. This is a 2x minus 63. That means since we divided by -7 and it had a remainder of 0, I can go and substitute -7, right? This means substitute -7 squared minus 2 times -7 minus 63. Substituting that -7 in. -7 squared. -7 times -7 is a positive 49. -2 times -7 is a positive 14 minus 63. 69 plus 14 is 63. Well, ain't that the coolest thing? If we get a remainder 0 when we divide by this number using synthetic division, that means if we substitute that number in, that is a 0, that is a solution. -7 is a solution to this equation. If we graph this, it's going to cross the x-axis at -7 because that equals 0 there. The y equals 0 when x is -7. Y equals, what was it? X squared minus 2x minus 63. And we said -7 is a 0. And sure enough, -7 is a 0. That is where it crosses the x-axis. Because our synthetic division had no remainder. That's one of the solutions. That's what x plus 7 is a factor. So x minus 7 is a solution. And there's the lesson summary.
Those are both plural.
Man. Steps. Set up the synthetic division problem. Follow the process by multiplying and adding.
It's
Identify
just
the
looking
quotient.
at like the singular and the
And
plural.
remember, remainder 0 means it's a factor. It does have some practice problems you can work here. We're not going to go through any. We're about out of time. But set this up as synthetic division. Divide by -2. There you go. 6
You're
problems.
like, oh, that poor hand only had one.
6 problems. And then there's create your own second degree that has a remainder 7. Your work may be very different, but
Yeah,
it
you got
should,
it. You're making it
should
harder.
work on that.
What letter is that?
All right, we're going to look at the
Crap, that's
assignment for this one. What is the quotient when
Yep.
you divide by x minus 2?
Okay,
Synthetic
let's-
division.
let's retreat.
X minus 2, synthetic division. What's the quotient? When f of x is divided by g of x, what is f of x divided by g of x? When this is what f of x is, and this is what g of x. X to the third, x to the squared, x and the constant. Oh, here's a good one. Given these 4 binomials, which one of these is a factor? So you need to do synthetic division 4 times, or however many times it takes you, to figure out which one of these is a factor. And here's another one.
I'm gonna try.
Given these 4, which one of those is a factor? All right, synthetic division. Synthetic division, have fun with that. Synthetic division is a pretty cool way to do polynomial division when you just have an x term, x plus 3, x minus 1, something like that. So, all right, guys, have a great week. We do not have class again because we have a double weekend. So there is no class Thursday or Friday. So if you have any questions, you can email me. I will be working Thursday and Friday because teachers do not have a 4-day weekend. But that's
So
okay.
think about
You
what kind
do.
of flag that is.
So if you have any questions, you can email me because I'll be checking email Thursday and Friday. All right. Have a great week, everybody. We'll catch you on the flip side.